Hello everyone, this is Harry Gill. Welcome back. And in this video, we are going to look into buffered readers and writers. In the previous video, we have seen the common method that exists in the abstract classes. In this particular video, we are going to concentrate on the buffered reading and buffered writing. We will specifically discuss buffered input stream and buffered output stream, but the exact same concept also exists for buffered reader and buffered writer. Now let's jump into IntelliJ. The aim of this video is to show you how much difference it makes and what is the benefit of using buffered input output stream rather than unbuffered one. So to save some time, I have written two different programs called unbuffered file IO and buffered file IO. And I'll go through the code line by line to explain you what it does. I will check in the code into Git and also share the link in the description. So feel free to check out and have a look. So what we are looking at right now is a unbuffered file IO class. So what this class is doing is we simply have a print statement to signify that a program started. We created a string builder and we are putting 5 million characters into the string builder, and that character I have chosen just A, doesn't matter what that character is, and then simply convert that string builder into string. So what I have done in this program is I am also keeping track of how long does an operation take. So in this case, I'm keeping a track of start time, and in this start time, what we do is we open a file and we convert the string that we created into bytes, and we write each byte, 1 byte at a time, into that file. And we have already seen this syntax in the previous section, so we will close here. And once we are done writing the whole file, we will also keep track of end. And then I'm printing file is written in, and then simply subtracting the values in these many milliseconds. Similarly, what I'm doing is I'm also again start keeping track of new time, opening the file, the one which we just wrote, and reading it byte by byte. I'm not printing anything because it's going to be huge data, so we don't want to worry about printing it. But effectively, once we are done reading, I'm keeping track of when we have completed reading, and finally I'm printing the total time it took to read the file. So first we will print total time it took to write the file and then read it. So 5 million characters will make about 5 MB of file. So this particular program is writing 5 MB of data and again reading it. So let me run the program. It's going to take some time, so I'm going to pause the video here and come back. All right, so the program has written the file and it took about 16 seconds to write the file. So in total it took 16,125 milliseconds, but it's about 16 seconds to write the file. To read the same file, it took about 5.5 seconds. Now, you can go back to the project and have a look that we have created a file called myfile of size 5 MB. And remember, we took 16 seconds to write and about 5.5 seconds to read. Now let's go to the buffered file IO class. As I mentioned, the program is very it's ditto copy paste. The main difference is that instead of simply using file output stream, we are now using a buffered output stream, which is high level class. And as the name suggests, it will do some buffering, and also have used a different file as my file too. And the only other difference is even to read it, we are using buffered input stream rather than simply file input stream. In the previous program, we were only using file input stream. Now let me go ahead and run this program. So as you see, I didn't pause or wait, and the program ran so quickly that it wrote the file in 79 milliseconds and it read the file in 35 milliseconds. You see the huge difference we have made, where previously it was about 16 and a half or 16 seconds, and now it's like 79 milliseconds. And previously it took about 5.5 seconds to read, and now it took only 35 milliseconds to read. And just to confirm, so now we have created a myfile2 and the size is 5 MB even for the second file. So this is, as you see, a huge gain in performance. The main difference in performance comes by the fact that BufferedInputStream and BufferedOutputStream, they buffer the data and interact with the file system in batches. Whereas FileInputStream and FileOutputStream, they interact with the file system byte by byte. So given that, because we are buffering the data, we have less round trips with the file system that's on the operating system, and that is where the performance gains comes from. In the real world, you will almost every time will likely and should be using the buffered input output stream instead of the low-level IO stream classes. While we are discussing about the buffered classes, I want to show you one more concept. So for that, let me create a class and I will call it as text file reader writer. And I'm going to create a text file. Let's name it as text file. And I'm adding some content to it. So I'm going to show you an example how the reading of the text file works. And the reason I'm showing this is we will see a new method that we haven't seen this. And this method is mainly useful for the text files. So I'm going to create a buffered reader. This is the file we just created. Going to define a variable of type string. So the read line is the method that I wanted to discuss. What this method does, and it's present in BufferedReader, which will only read the character stream, means it will read the text file. So what this line does, as the name suggests, it will read one line at a time, not a byte, and not also, we don't have to provide the size. We can say read a line and give it back to me. And when the file ends, this returns a null. So that is how we know that we have read the whole file line by line. I'm going to print that line that we have just read. And also what I will do is I'm going to create a BufferedWriter. Let's name the file as text file copy. And in BufferedWriter, I'm going to simply write what each line. So we read a line here, we printed that line, and now we wrote that line into the new file. Note that I haven't used the try with resources, so I will have to close the input and output stream explicitly. All right, now let's run the program. I think I named the file incorrectly. Let me fix that. Sorry, the reason is I put the file in the wrong place. It should be at the root of the project. Now let's rerun. Cool. So we got these outputs, which is the print statement we had in the program, this one. And we have already created a text file copy. Let's open it. And what we see here is that we did read all the lines, but we have kind of merged them into one line instead of 3 lines. And the reason for that is the read line method, it reads the content of the line, but it does not read the new line character, which is at the end. So we have to explicitly write the new line character. So the new line method will insert a system specific new line. So remember that the Linux system has a different new line character than the Windows system. The Java language is not system dependent. So this particular program will run on both Linux type of systems and Windows. So the new line internally, it identifies which system it's running on and it appropriately inserts that particular new line character. Now let's run the program again. And this is the copy file. And as you see, now the content of the copy is properly what we expect. That brings us to the end of the video. If you like the content of this video, hit the like button and subscribe my channel for future videos notification. Thank you so much. I'll see you in the next one.